Hello friends, welcome to my channel, myself Parag Zambulkar. In this video, we will see virtual function, pure virtual function and abstract classes in C++ language. For that, we will see one example and from this example it will be very clear. But before that, we will see these two concepts. One is compile time polymorphism and runtime polymorphism. So many times we use these words. Polymorphism is poly means many, morphism is form. So polymorphism is multiple form. Single thing having multiple forms is called as the polymorphism. Now what do you mean by compile time polymorphism? When we are achieving polymorphism at compile time, so it will be compile time polymorphism. And runtime polymorphism is when we achieve polymorphism at runtime, it is called as runtime polymorphism. So we achieve compile time polymorphism by function overloading. Function overloading. So function overloading or constructor overloading. So what means function overloading? When multiple functions having the same name but they are different in return type or some parameters that they are accepting. So this is the function overloading. Functions with the same name but they have different prototypes. That means different return types and different parameters. So that we call function overloading. Runtime polymorphism is achieving polymorphism at runtime and it is achieved by function overriding. Function overriding. Now what do we mean by function overriding? So here functions have the same name but different prototypes. But in function overriding, we have different functions with the same prototype also. That means they have the same name, they have the same return type, they have the same parameter they accept. So that is called as the function overriding. So we'll see one simple example of runtime polymorphism. For example, suppose we have a shape class and we have a draw method of this shape class, draw function of shape class. Now see, at runtime we want to decide so whether which shape we want to draw. Suppose we want to draw circle. So for that we have circle class and again we have draw method or function for that. At runtime suppose we want to draw rectangle. So we will have rectangle class and again we will have draw function for that. Again suppose at runtime we want to draw triangle, so for that we will have triangle class and there will be draw method or draw function. So here see, this is a general shape class, so we will make it base class. In Java language we will say it is a super class and all this circle class, rectangle class, triangle class, all these will be the derived class. Now at runtime we have to decide which shape should be drawn. So at runtime we have to decide whether should we draw circle or rectangle or triangle. So accordingly that draw method should get executed. Now see here what we will do, we will create object or pointer of shape class and to that pointer we will allocate address of objects of these derived classes. So at runtime, when we'll allocate address of circle class object to pointer of shape class, so it will draw circle. When we are allocating address of object of rectangle class to the shape class pointer, so it will draw rectangle and similarly triangle. So in this way, we'll achieve runtime polymorphism. So for that, we'll see the example, and from that, we'll find out what do you mean by virtual function, pure virtual function, and abstract class. So now we'll move to example. Now look at this. So here I have written shape class. So this code is from the C++ language. So I have written shape class, that will be our base class, and one general method is written there. General function is written there. So actually we are not drawing any shapes here. So simply we are putting one message. So this is a draw function of shape class and here we are putting one message, drawing any shape. then circle class, and this is the rectangle class. These are the derived classes of shape classes. So here we are inheriting shape class. So in circle class also we have draw method function, and in rectangle class also we have draw function. Here we are putting message drawing circle, and here we are putting message drawing rectangle. Now see, this is the main function. In main function we have created pointer of shape class, then we have created object of circle class. This is the derived class, and to this pointer we are giving address of this circle class object, and then we are calling draw function. In the same way, we are defining object of rectangle class. We are allocating address of this object to shape class pointer, and then we are calling this draw function. So in this way we have written this program. Now we will run this and we will see what output we will get. So we are compiling it and then we are running it. Now see, both the time we are getting this output, drawing any shape, and this is the output from the draw function of shape class. Draw function of shape class. Actually what we were expecting, so we have created pointer of shape class, and to that pointer we are allocating address of circle, and then we are calling draw function. So we were expecting we should get that draw function from the circle class should get run. So we should get a message accordingly, that is a drawing circle. Then in this way, in this statements, we are allocating address of rectangle class object to this pointer, shape class pointer. So we were expecting we should get this message drawing rectangle, but in both the case we are getting message drawing any shape. That means draw function from shape class is getting run, and shape class is the base class. So function from the base class is getting run, not from the derived class. This is happening because this function is get inherited here. So there are two draw functions, one draw function from the circle and another draw function from the shape, and same thing is happening here. There is one draw function from the rectangle class and another draw function from the shape class, and in that situation shape draw function from the shape class as parent class is run. But we don't want that. At runtime, what we want to decide, at runtime we want to draw circle, at runtime we want to draw rectangle, so that we want to achieve. And for that purpose we have to make this function invisible. We want to make this function invisible in these classes, and to make this function invisible in these derived classes we have to make it virtual, and it can be made virtual by using this keyword virtual. So we have used this keyword virtual, and now this function will be virtual in these classes. And because of that, whenever there is a confusion, there is a conflict that there are multiple functions with the same prototype, at that time this function will be run as this will be the virtual. At that time this function will be virtual. Now we will see the output. So same program, just we have added one keyword virtual here. So again we will compile this and now we'll run this. So now you can compare the outputs. So see, in the first time when we have not used this virtual keyword, so we got this output drawing any shape. So this message we got from the draw function of shape class. Now look at this. Here we got these two messages, drawing circle, this message, drawing rectangle, this message. So these are the messages from the derived classes. So here we have achieved runtime polymorphism, and to achieve runtime polymorphism we have made this function from the parent class virtual. So this is the virtual function in C++ language. Now see, so at runtime we want to decide whether we want to draw circle or rectangle. So there is no need to write any statements, right? So at runtime we want to decide. So either we'll draw circle or rectangle or any other shape. So there is no need to write statement for this, right? So instead of writing statements here, what we can do, we can remove this. At there is no statements are written for the draw function of this parent class. So as there are no statements, so in C++ we'll make this one arrangement, that is we are making it is equal to 0. So we are telling compiler that there are no statements written for the draw function of shape class. So here there is no function. Now see, if I run this, so we'll compile this first and then we'll run this. Same output we are getting. So what we have done, previously there were some statements written for the draw function of this parent class. Now we have removed that statement and here we have allocated 0. And when we compile and run this, we got the same output. Now such functions are called as pure virtual function. Such functions are called as pure virtual function. There you can see. So virtual functions without any body, without any statements are called as pure virtual function. So this will be the pure virtual function. Now see, there was one more concept, that is the abstract class. Now what do I abstract class? Keep in mind, any class with pure virtual function, at least one pure virtual function, that class becomes the abstract class. See, again I am repeating, any class with at least one pure virtual function becomes abstract class. What do you mean by that? What do you mean by abstract class? It is a class which cannot be instantiated. That means we cannot create any object of that class. So such classes are called as abstract classes. And how abstract classes are defined in C++ language? So any class with at least one pure virtual function. If single pure virtual function is there, so that class become abstract class and we cannot create object of that class. So in this case, in our example, this class has become abstract class. Now there is one important thing, so that already we have seen, so it is the abstract class, so we cannot create any object of this class. But keep in mind, wherever we are extending that class, there compulsorily we have to write body or we have to implement this pure virtual function. So see, this is a pure virtual function. We have extended this class, shape class, in the circle class. So compulsorily we have to implement or we have to write statements or we have to write body for this pure virtual function. This is a pure virtual function and here we are implementing it. Here we are implementing it. So compulsorily we have to do that. If we don't implement this pure virtual function here, so this class also becomes abstract. Suppose if I remove this, then this class also become abstract. So it becomes abstract in the sense we cannot create object of this class as it becomes abstract. So compulsorily we need to implement this pure virtual function from the base class in the derived class wherever we are implementing it. Okay, so this is the abstract classes. So in this way we have seen virtual functions, pure virtual function and abstract classes. So all the concepts are used to achieve runtime polymorphism.